Welcome to Kinetic Energy and Elastic Energy Stores. So what is kinetic energy? So kinetic energy is the energy in moving objects. Those moving objects could be a car driving down the road. It could be a stream of water flowing down the stream. It could be a plane just flying in the air. So the energy in moving objects is also called movement energy or kinetic energy. Now, kinetic energy has a formula. Let's just write this formula down for you. So kinetic energy, how do you work out kinetic energy? Well, the formula is half, or in other words, 0.5, multiplied by the mass. Mass means weight. It could be in kilograms or grams or anything bigger in tons, multiplied by speed, and then we square it at the end. So in other words, half times mass, which is the weight, multiplied by speed squared. This is the formula for calculating kinetic energy. The second topic that we're looking at within this whole topic is elastic potential energy. Now, elastic potential energy is all about work which is done when let's say, for example, a spring is extended or compressed or twisted or stretched. And elastic potential energy is stored in that particular spring. And the formula for calculating elastic potential energy is as follows. So elastic potential energy, the reason we call it potential is because that could be the potential energy that could come out of that spring if you were to stretch it or twist it, or if you think about an elastic band, for example. What's the energy that will actually come out in future reference? So elastic potential energy is the energy stored in an elastic object, any elastic object, when work is done on that object. And the formula is as follows. So it's half, same as before with kinetic energy, 0.5 or half, multiplied by the spring constant. Now, spring constant actually means, let's say, for example, newtons per meter. Let's say, for example, in other words, the force that is applied multiplied by the extension. An extension means how far does it actually stretch? Okay. So first we have what we call 0.5 or half multiplied by spring constant, which is the force that's applied per meter. So newtons per meter as an example. Let's just write that down here, newtons per meter as an example. And then multiplied by the extension. Let's say, for example, if this particular spring or band extends for like a meter, let's say, for example, in terms of distance, and then you multiply it by the extension itself. So elastic potential energy is always measured in joules, and spring constant is always measured in newtons per meter, which stands for N/M. And the extension itself at the end is referring to the increase in length, and this is measured in meters. Okay, so if you'd like to watch this video again one more time, do have another look. In the meantime, you've got some imagery there with some more information and then questions to answer thereafter. Good luck.